Hi AP Calculus students. We are working out problems in section 2.6b. Thank you for sending me your requests, and you asked all of them, which isn't surprising because it is a very hard section and it was the hardest part of the hardest section. So I'm going to do all the problems. If there's specific ones you need, of course you can fast forward to those. I'm going to do these kind of quickly so you can, rewind if I've gone too fast. Problem number 20. Find the rate of change of the volume, that's dV dt, if the rate of change of the radius, that's dr dt, is 2 inches per minute, and the height of a cone is 3 times the radius. Now, notice I tried to draw it so it kind of matched that. When r equals 6. And that was for A, and you can do part B. Okay, so the first thing we need to do is write the volume of a cone, 1/3 pi r squared h. Now, notice that they're giving us a dr dt, and they want dv dt, but they didn't ask for dh dt, and they did not give it to us, meaning that we cannot keep this h here, because when I take the derivative, there will be a dh dt in there, and I don't have it, and I don't want it. So this means that I have to substitute the h, and notice they told us above that h equals 3r. So let's go ahead and update our formula, and we will replace h with 3r. That causes the 3's to cancel, and we get the volume is pi r cubed. There we go. Now we can take the derivative of both sides with respect to time, and we get dv dt equals, let's take the derivative here, that'll be 3 pi r squared times dr dt. Right, kept my pi, brought the 3 out front, multiplied it, reduced the exponent by 1. They asked us for dv dt, right? And so we have to have everything else. And notice they told us r was 6 and that dr dt was 2. And so you can just pop those values in to solve. On number 21, it's a cone also. They have a cone a lot on the AP exam. Okay, and so in this case, there is sand that is coming off of a conveyor belt that is being poured onto a conical pile. The sand is coming in at a volume rate of 10 cubic feet per minute, and they said that the diameter equals 3a, which is the height right here. They called it the altitude. At what rate is the height a of the pile changing when a equals 15? In other words, they're asking us for dA dt. Now, there's a couple ways I could have gone here. I could have called AH, right? And but what I did is I wrote the volume formula for a cone and just said, hey, you know what? They're calling that HA. So all I did was make this quick substitution here. Now, like in the last problem, number 20, though, notice that let's see, dV dt they gave us. They are asking us for dA dt, right? However, they did not give us information about r or dr dt or ask us for it. So this r has to go. And this is going to take just a little extra step, because here's what they told us. They told us d, the diameter, equals 3 times the height. Well, I don't have a diameter in my formula, right? So I'm first going to say, well, you know what? A diameter is really 2 times a radius, right? So all I did was replace the diameter with 2 radii, right? And now to get the r alone, I'll just divide both sides by 2. So what I actually need to do is that the radius is equal to 3/2 a. And that is going to be my substitution right here. So let's fix up our volume formula. That would be 1/3 pi, and that would be 3a over 2 squared times a. Okay, let's fix it up a little bit more. The volume would equal 1/3 pi times 9a squared over 4 times a, one more step. The volume equals, let's see, this 3 will cancel and leave a 3 here. And I now have 3 pi over 4 times a cubed. We are now ready to take the derivative with respect to time. Here we go. We'll do that in green. And that would be dv dt equals, we'll bring this 3 out front and multiply it. That would be 9 pi over 4, reduce that exponent by 1, times dA dt. Okay, let's go ahead and circle what they asked us for. They asked us for dA dt. That means that I need dv dt, and they gave that to me. It is 10. I also need a. They gave that to me, and it is 15. So the problem you have right now is 10 equals 9 pi over 4 times 15 squared times dA dt. And so now all you have to do is work to get dA dt alone carefully. That was number 21. Next, number 22, still working on a cone. Here we go, one more cone. Notice that they said that water is coming into a conical tank that is facing with the vertex downward. They said that the whole cone is 10 feet across, meaning the radius is 5 across, and that the total height is 12, right? And so they said water is coming into a tank at a rate of 10 cubic feet per minute, and they want us to find dH dt, that would be the height, when the height equals 8. So notice I made a water level of 8 here. And here is the formula for the volume of a cone. Just like the last problems, you're kind of getting used to this. They asked us for dH dt, right? They did not give us dr dt, and they didn't ask for it. So this R must go. How do we do that? We need to set up a proportion. The cross section of this conic tank is a triangle, right? And if you notice this diameter or radius across the top, anytime you put water into it, it would be parallel to that base. And so we do know that there is a triangular proportion going on here, where this is the large triangle here, and we might as well make the water blue, right? And here's the smaller triangle. So here's what we know. As that tank fills, that if the whole tank was full, the ratio of the radius to the height would be 5/12. And that ratio remains no matter how much water is in the tank. Now we need to replace the R, so I'm going to multiply both sides by h. And that tells me that the radius is always 5/12 of the height. And we are going to substitute that in. And again, as we did in the last problems, fix up our volume formula. So the volume is 1/3 pi. My R squared is 5/12 h, square on the outside. There you go, 5/12 h squared times h. Okay, let's fix that up a little bit. The volume is 1/3 pi times 25 over 144 h cubed. Okay, and then 144 times 3 is 432. So we have 25 pi in the numerator, but you know what I'm going to do? Watch this. I'm just going to put 3 times 144 in the denominator. You'll see why. Okay, and h cubed. Let's take the derivative with respect to time. There we go. and we get dv dt equals, when we bring the 3 out front and multiply it, notice it cancels. That's why I kept it separate. And I have, oh, did I forget my pi? There we go. I didn't bring my pi from where I'm pointing down. I was working so hard on those darn numbers. So there we go. I brought the pi down. 25 pi over 144. We reduce the exponent by 1 and multiply by dh dt. And they were asking us to find dh dt, so we need everything else. dv dt is 10, right? And they gave us when h is 8. There we go. So you can do the rest of the math yourself on that one. Okay, let's continue. Number 28. On number 28, there is a dock that is 12 feet tall here, and there's a boat, like my boat, that's being pulled in on a rope, right? So someone's at the top of the dock, and they're turning this wheel, right, to pull the rope in at a rate of 4 feet per second, drdt, labeled at r, and they want to know what speed is the boat coming in. Well, notice that the speed of the boat is traveling along the water, and that is a horizontal speed, right? And this distance is getting smaller. So they asked us for ds dt, and I labeled this side s, that's the side that's changing, and they want to know how fast is the boat coming in when the rope is out 13 feet. So let's take a look. Notice the dock is perpendicular to the surface of the water. So what I actually have is the Pythagorean theorem here, right? And so I'm going to go ahead and write that. That would be the side of 12 squared, right? Because that dock throughout the problem is 12 feet, right? It's a constant. 12 squared plus s squared equals r squared. There we go. Let's take the derivative with respect to time, and we get a 0, and then 2s ds dt equals 2r dr dt. Okay, notice you could also cancel out the 2's, right, because you can divide both sides by 2, right? That makes it a little nicer. Let's circle what they were asking us for. They were asking us for ds dt. This means we have to have everything else, right? We need s, we need r, and we need dr dt. Now notice we have the r, they said that's 13 feet, and we do have dr dt, that's 4 feet. But it feels like we don't have the s, but we actually do have the s, because at the moment, let's go to our picture, at the moment that the rope is 13, so the hypotenuse is 13, and this vertical side is 12, and using the Pythagorean theorem, we could quickly figure out that when the rope is 13 feet out, that would make this base of this right triangle 5 by the Pythagorean theorem. This makes a right triangle 5, 12, and 13, and so we do have the 5. There we go. Now you can pop in your values and get ds dt alone. Let's look at number 30. We have lots of problems with airplanes. Okay, so there is an airplane that is flying over a radar station right here. It is 5 miles up. That is its height, and it's maintaining that altitude. So it's flying along this horizontal path, which they actually labeled X in the book. And so notice that this is the speed of the plane, but of course, this is also the speed of the plane, right? Because if someone is on the ground, that is like the ground speed of the plane, because these are both horizontal. So this is the actual distance. If you did a straight shot from the radar to the plane, like just traveled along, that is the actual distance that the plane is from the radar. So the book says when S is 10 miles, the plane is traveling at 240 miles per hour, and they want to know what is the speed of the plane, and they mean dx dt. So I know that when they say ds dt is 240 miles an hour, they're saying that's the rate that this length is changing. That is not the actual speed of the plane. The speed of the plane is its speed in reference to the ground. It's horizontal speed. So they are actually asking us for dx dt here. Okay, well, let's look at the picture and see if we can relate the information. I hope I got the 240 right. Let me look. That seems kind of slow for a plane. No, it is 240 miles an hour. So notice again, vertical distance up, traveling at a horizontal path. Again, we have the Pythagorean theorem. So let's take a look. That would be 5 squared plus x squared equals s squared. We will take the derivative with respect to time, right? And we get 0, and 2x dx dt equals 2s ds dt. Notice you don't have to, but we can cancel the 2's from both sides. They asked us for the speed of the plane. This means we need the x, we need the s, and we need the ds dt. Let's see, ds dt they gave us was 240. S they gave us was 10. Notice again we don't have the x, but as you now know from the last problem, we actually do, right? If this side is a length of 10, we can use the Pythagorean theorem to find this x right here. So I am going to, I'm going to go ahead and do that. Let's see, so that would be, I can see this isn't actually going to come out pretty, so I'm going to take the square root of, that would be the hypotenuse squared minus the side squared, and that would give us 8.66 would be the x length. I'm not sure if you can see that way up there, 8.66, and we'll put it right here. Okay, now you have all the information you need. Pop it in to get dx dt. Problem number 31 is an interesting problem. Right here, it is a baseball diamond. Now, baseball diamonds are 90 feet sides, right? And of course, this is because it's a diamond, right? It's a right angle right here. And what they're saying is, you know, here's home, first, second, and third. And a player is running from second to third. Okay, so I made an arrow. He's running in. Okay, and it says he's running at a speed of 25 feet per second. And he's 20 feet from third base. So that's how I knew where to put the P, because if the player is right here, is this P or is this P? Well, they said he is 20 feet from third, so I knew to label this side right here P, right? And so his speed is dp dt. And notice because that side is getting smaller, we're going to call that a negative 25 feet per second. At what rate is the player's distance s from home plate changing, right? And so here's home plate. Of course, he's moving into third, but at what rate is his path from home plate changing? So they are asking you, here's how far he actually is from home plate, and they are asking you for ds dt. Notice again, right, we're seeing patterns here. Pythagorean theorem, right? So we have 90, what's the hypotenuse? The hypotenuse is yes. So we have 20 squared plus 90 squared equals s squared. Oops, cross out. Sorry, I forgot. The 90 feet is always true, right? Because this side is always 90 feet. This side is not 20 right now, right? It is changing. It is just at this moment in time. So I have to call this side P because it is changing. And then later when I take the derivative, then I can put in the 20, right? It is not a constant. The 90 feet side is. Okay, let me try that again. P squared plus 90 squared equals s squared. There we go. Take the derivative with respect to time, and we get 2p plus 0 equals 2. Oh, I'm getting close to the end. I'm making mistakes. Stick with me. Let's fix this in green. All right, let's slow down, Miss Culver. Let's slow down. 2p dp dt. That's what I missed, right? I think I just need to calm down here. Let's see. I'm looking at the video and it's 20 minutes long and I didn't want it to be too long for you. Anyway, I corrected my error right here. The derivative here is 0 equals 2s ds dt. Hey, at least you're seeing some common mistakes that can be made when you're doing this. Okay, let's cancel out those 2's again. We're seeing this pattern happen over and over. They're asking us for ds dt. We need the s, we need the dp dt, and the p. Let's see, they gave us the p is 20. Now I can use it. They gave us dp dt is negative 25. Again, now you know that you do have the s, right? It feels like you don't, but when you go to the picture, when this side is 20, this side is always 90, we can use the Pythagorean theorem to figure out that hypotenuse. So let's go ahead and do that. That would be the square root of 20 squared plus, right, because it's the two sides, 90 squared. And there we go, 92.195. 92.195. There you go, and you can finish up that problem with those values. Let's move on to number 42. There is a balloon rising in the air. I called this a height. And they said that the height that the balloon is rising is 4 meters per second. And they told us that an observer is 50 feet, so that stays constant in the problem, from the point where the balloon left the ground. And they want to know what is the rate of change of the angle of elevation, d theta dt, right? Because notice that this person right here is looking upward, right? His angle is changing as time goes by. When h equals 50. Okay, so notice that because I have a side of h and a side of 50, and I have an angle, I have to use trig, not the Pythagorean theorem, to relate this. So when I look at this, I would think that I would say that tangent of theta equals h over 50, or if you don't mind, I'm going to put 1/50th h, because I know when I take the derivative to use my constant rule, but h over 50. Okay, let's take, I think, I don't need to substitute. Let's take a look. Let's take the derivative with respect to time. Okay, that would be the derivative of tangent is secant squared theta, right, times d theta dt equals the derivative, this would be 1/50th, the derivative of h is 1 times dh dt. Okay, now let's circle what they're asking us for. They are asking to find d theta dt. This means we need theta and we need dh dt. Notice you have dh dt, it is 4. Theta, it would appear we don't have, but of course, as you're starting to learn, we actually do. They told us h equals 50. So take a look here. So when the height is 50, so here's the observer. The side opposite him is 50. The side adjacent to him is 50. So at this moment when this height is 50, tangent is 50 over 50, or tangent is 1. And we know that that happens at 45 degrees, or pi over 4. There we go. Now you can pop that information in, work out secant, work out it being squared, and work to get that d theta dt alone. Last problem, another airplane. Here we go, number 44A. This time the plane is traveling horizontally 5 miles up and is coming towards this observer here, right? So if this is the horizontal speed of the plane, this is also x, the ground speed. And they are saying that the speed of the plane horizontally, dx dt, is a negative 600 miles per hour. And they want us again to find d theta dt when theta equals 30. Okay, so notice again, I'm not using the Pythagorean theorem. I do have a right triangle, but I have to use trig because they're bringing in the angle. So notice it's pretty tempting to write, and I would agree that I have from this angle an opposite side and an adjacent side, right? So I'm tempted to write tangent of theta equals 5 over x. And if you keep going in this manner, you'll be just fine. But not a huge fan of having the x in the denominator, right? Because now it's to the -1, and you know, I'm working with negative exponents. So I would think that I should take the reciprocal of both sides. So cotangent of theta equals x over 5, or 1/5 x. I think I would prefer to work with this formula here. So let's take the derivative of both sides with respect to t. The derivative of cotangent is a negative cosecant squared theta times d theta dt equals 1/5. The derivative of x is 1 times dx dt. And let's take a look. They asked us for d theta dt. There we go. My dx dt they gave me, that's a negative 600 miles per hour. And they did give me theta. It is 30 degrees. So I do have everything I need to solve for d theta dt. I am trusting that you can very carefully find first sine of theta, right? Sine of 30. Take the reciprocal, square it. Don't forget your negative, right? And work to get d theta dt alone. Now, in the back of the book, the answer that they give, so once you get your miles per hour, it's d theta dt, so it would be degrees or radians per hour. You'll find that they chose to switch it to minutes by dividing by 60, just because, so the answer you get in degrees or radians per hour is absolutely correct. Why did they put it in minutes? Because this plane is going so fast that there's no way you would really be standing there for an hour, right? So they switched it to how your angle is changing per minute. So just understand that when you see the answer, they switch from hours to minutes without really saying that they wanted you to. So I hope this went well for you. We will definitely talk about these problems, but I hope this clears up a lot for you. Have a great evening.